In the previous video, we decoded the Pi network whitepaper. We found an excellent vision, but it came with a very blurry map. Today, we will temporarily set that map aside. We will open the hood, explore for ourselves, and examine the engine itself. A cryptocurrency can only be as strong as its underlying technology. Pi claims that it is built on the proven stellar consensus protocol and relies on thousands of community nodes to make that engine run. But is that technology truly legitimate? Is it as robust and secure as the blueprint claims? In this video, we will conduct a deep technical analysis. We will clarify the consensus algorithm and explore the vital role of Pi nodes. This is the technical foundation you need to know. Welcome to Pi Decoded. Part 1. What is a consensus protocol? Before diving into Pi's specific technology, let's answer a basic question. What is consensus in blockchain? Imagine you and 10 friends want to decide on a restaurant for dinner. Everyone texts back and forth, votes, and finally, all agree on one choice. That process of reaching group agreement is consensus. In blockchain, the idea is similar, but on a much larger scale. Instead of friends agreeing on a restaurant, thousands of computers worldwide agree on which transactions are valid and should be added to the public ledger. Bitcoin achieves this through an extremely competitive and energy-intensive race called proof of work. It is secure but slow and costly. Pi, as stated in its white paper, has chosen a completely different path. Part 2. Deconstructing the Stellar Consensus Protocol, SCP. That path is the Stellar Consensus Protocol, or SCP. It was created by the world-renowned computer scientist and Stanford University professor, David Mazieres. So right away, we know its origin is academically legitimate. Unlike proof of work, SCP has no miners. It has voters. It is a federated voting system. But how do you prevent chaos with thousands of computers trying to vote simultaneously? The genius of SCP is a concept called quorum slices. Let's use a metaphor. Imagine on social media, you have a circle of close friends whose opinions you trust. That is your quorum slice. Each of your friends also has their own trusted circles. A decision across the entire network, or a quorum, is reached not when everyone agrees, but when enough overlapping trusted circles agree with each other. Consensus spreads through the network like a wave. The advantages are clear. Speed. Transactions can be confirmed in seconds, not minutes or hours. Environmentally friendly. It uses a tiny fraction of the energy compared to Bitcoin, as there is no computational race. Low cost. No need for expensive specialized hardware. But like any technology, there are trade-offs and risks. SCP's security depends entirely on the configuration of these quorum slices. If many lazy nodes all choose to trust the same central group of nodes, such as those run by the core team, the network can become effectively centralized, defeating its purpose. There is also a theoretical risk of partition failure or network stall if key nodes go offline. SCP is not a perfect system. It is a system with a distinct set of strengths and weaknesses compared to Bitcoin. It trades absolute security, guaranteed by the energy of proof of work, for speed and efficiency. Part 3. Pi node, the true guardians. So, how does Pi use this powerful SCP engine? Through the Pi node software that thousands of community members run on their home computers. If you run a node, you are the true guardian of the Pi ledger, not the app on your phone. So what does the node software actually do? When you run a Pi node, your computer connects to the network. It listens to transactions, runs them through the SCP algorithm to vote on their validity with other nodes, and helps the network reach consensus to form new blocks on Pi's blockchain. You are actively participating in securing the network. The requirements to run a node are fairly standard for a modern computer, and it is designed to run in the background. The incentive to do this, besides supporting the network, is the node bonus, which increases your personal mining rate. Most importantly, the more independent, reliable nodes there are worldwide, the more decentralized and secure the Pi network becomes. The network's strength truly depends on the quality and diversity of node operators. So, after this deep technical analysis, what is our conclusion about Pi's engine? The answer is clear. The technology is legitimate and authentic. The Stellar Consensus Protocol is a respected, peer-reviewed, and proven technology created by a world-class computer scientist. The Pinode software is the means by which the community runs this engine. From a purely technical perspective, the foundation is solid. But, and this is the most important part, a powerful engine is useless without skilled drivers and a clear road ahead. The deployment and configuration of that technology are what really matter. The decentralization and security of Pi's future network depend entirely on the diversity and independence of node operators and their trust graphs. The engine is real. Now we must ask, what is its fuel? What gives any cryptocurrency real, tangible value? In the next video, we will begin our most important series, Economic Analysis. We will start by tackling the biggest and most controversial topic, Pi's tokenomics, and the burning question about its total supply. You won't want to miss it. Subscribe and hit the notification bell so you can continue decoding Pi with us. Thank you for watching.